Hey guys, welcome back. I hope you all had a nice break. Today we're going to talk about the difference of squares. So the difference of squares is in reference to when you're factoring and you have the difference of two perfect squares, like x squared minus 49. And you're trying to factor to see what was multiplied to get here. Now notice, this isn't a trinomial, it's a binomial. So we're trying to think back to patterns in the past that, if you think of like our trinomials from the past, we have this form, the a squared plus 2ab plus b squared. We're trying to think back to which ones ended up with that middle term disappearing, that middle term going away, and we were subtracting the b. And this is why I said memorizing those patterns would be so important, because here the pattern that ends up with a squared minus b squared, when we multiplied, that was when we had a plus b and a minus b. When we multiply this out, remember we do the product of a sum and difference, we end up here. So factoring is going backwards from that, going from this to what was multiplied to get there. So in order to do that, we're going to take what we have here. This is like the a squared minus the b squared. So we're really going to take, if you look going back from here to here, it's like you're taking the square root of each one. The square root of a squared is a, square root of b squared is b, so it's a plus b, a minus b. So here, this would factor to, well, x plus 7 and x minus 7, because the square root of x squared is x, so that's going to go right in here for the x's, and then the square root of 49, which is like your b squared, well, that's 7. So you're going to add 7 for one, and you're going to subtract 7 for the other. This is another pattern we're going to look for when we factor. It's called a difference of squares. If we were to multiply this out, we would end up with x squared minus 7x plus 7x minus 49, and the middle terms are going to cancel. So this would, in fact, get us back to where we started. So our factored version of this, in factored form, is right here. And again, this is another pattern we're going to look for. We call this the difference of squares. So when factoring, when we come across different polynomials or expressions that we're trying to factor, if we ever have a squared minus b squared, so you have a perfect square minus a perfect squared, we have two terms here, it's going to factor to be a plus b times a minus b, or a minus b times a plus b. You can change the order of the two binomials that you're multiplying together. So an example of this that we have listed right in here on the second slide is x squared minus 25. Well, these are both perfect squares, so it would factor to x plus 5, x minus 5, or x minus 5 times x plus 5. And then we have another example right at the bottom. See if you can do that one on your own. That would be t squared minus 64. What does that factor to? And with the difference of squares, they're both perfect squares. We're subtracting them. So this does fall into the category of a difference of squares. It's going to be t plus 8 times t minus 8. Or if we prefer, it's going to be t minus 8 times t plus 8. So that's how we can factor a difference of squares. It's just a different pattern that we're going to recognize. So along with GCF and trinomials, now we have, if we recognize two perfect squares being subtracted, we can use this technique to factor them. So let's go on to some examples. We'll see different scenarios with this. So our first one that we have here now, onto the third slide, we have 16x squared minus 25. So if you want to use difference of squares, well, you have to make sure that they're both perfect squares. You'd be in that form a squared minus b squared. And then you'd factor to a plus b times a minus b. So we need to see if this is represented as something squared. In order to do that, you would be taking the square root of 16x squared. And we haven't talked a lot about radicals and how to simplify like a square root like this, but we could, if we wanted to, we could do it with exponents. We have talked about exponents. This whole thing would be like raised to the 1/2 power, which would be 16 to the 1/2 power times x squared to the 1/2 power and then we would end up with 4x for this. So this is a perfect square. Your square root of 16x squared is 4x. We haven't talked about this yet, but you could also do this like the square root of 16 times the square root of x squared. Square root of 16 is 4. Square root of x squared is x. So your a, if you're using this form, your a would be 4x. If you square 4x, you get 16x squared. So when we factor, it's going to be a 4x where your a is. And now minus 25, well, we should know that the square root of 25 is 5. So your b squared is 25, meaning your b, or the square root of 25, is 5. So we have a plus 5, and we have a minus 5. So this would be factored form of 16x squared minus 25. In factored form looks like this. We have it now as two binomials times one another. So let's go on to another one. We have 16h squared minus 9a squared. 16h squared minus 9a squared. So again, to use difference of squares, we're going to need two terms. We do have two terms. We're subtracting. There's a difference. And these both need to be perfect squares. So square root of 16h squared, I'm going to use this. That's like the square root of 16 times the square root of h squared. So this is a perfect square. The square root is 4h. We can check to see if this is a perfect square. Can you take the square root of 9a squared? Well, that would be the square root of 9 times the square root of a squared. Square root of 9 is 3, square root of a squared is a, so it does work. We are subtracting two perfect squares, and this would be your a, and this would be your b term, if we're talking about this form up here. So this would factor to, well, your a is 4h, so 4h, 4h, and your b, you're going to add one of your b's. Our b is 3a here, so you're going to add one, and you're going to subtract one. So this is the factored form of our 16h squared minus 9a squared. So here we are factored out. All right, let's look at a couple more, then you'll try some on your own and see how you feel with them. So our next one, we have 121 minus 4b squared. 121 minus 4b squared. Well, 121, you can factor that, or sorry, you can take the square root of that. So your a would be 11. Square root of 121 is 11. And then your 4b squared, can we take the square root of that? Because your b squared is this whole term. So your b would be the square root of that. And that would be, well, square root of 4 is 2. Square root of b squared is b. So 2b. So your b is equal to 2b here. We're just using the term b as in the general form. So when you factor this, your a's are 11. So it's 11 and 11. You're going to add one of your b's plus 2b. You're going to subtract the other b term here. So minus 2b. This would be the factored form of 121 minus 4b squared. All right, on to our next, and then we'll have a few to try on your own if you want. So our next one, we have 27g to the third minus 3g. And if we look here, we might notice these aren't perfect squares. So we can't use the difference of squares right now. But when we factor, the first thing we should always look for is there a GCF? And in all the past ones, there wasn't a GCF. But here, there actually is a GCF. In common, both of these two terms have a g and a 3. So you can factor out a 3g, and you're left with 9g squared minus 1. So we've taken a GCF out. Now here's where a lot of people just kind of stop and they think they're done. But after you factored one step, you possibly could factor further. And here we want to examine this binomial. We have two terms, and we're subtracting, so it could be a difference of squares. Let's check. Is 9g squared a perfect square? Well, can you take the square root of it? Square root of 9g squared would be the square root of 9 times the square root of g squared. So that would be 3g. So our a term here would equal 3g. So we can take the square root of this, so this is a perfect square. And 1, well, that is a perfect square. The square root of 1 is 1. So b is equal to 1. So let's go ahead and factor this. This is a difference of squares. And we just found out the a term was 3g. And the b term is 1. So one of them you're going to add, one of them you're going to subtract. That's how a difference of squares works for us. So our final factored form, completely factored, is 3g times the quantity 3g plus 1 times the quantity 3g minus 1. So this is factored, but this is the completely factored form, because you can still factor further from here. And you want to get all the way to where there's nothing else you can factor out, which is this form right here. Alright, so if you're feeling okay with these, you can go ahead and practice some on your own. If you want to try more, there's a slide with 4 problems. I'll go through those 4 so you can check and see how to do them. So the first one in these 4 is the top left. It is 64x squared minus 25. If you want to try it on your own, feel free to go ahead. Here, you might notice, and as you start to do more of these, you might start to notice really quickly. Obviously, 2 terms, we're subtracting. We should be thinking, is it a difference of squares? And this is a perfect square, 64x squared. The square root of that is 8x. So your a term is 8x, and your b would be 5 here. So 8x plus 5, 8x minus 5. This is the factored form. Our next one was our 9x cubed minus 4x. So right off the bat, we might notice it's not difference of squares right away, but we do have a GCF. We have an x in common, so we should factor out an x. So x times 9x squared minus 4. Now here you would double check and say, well, is this a difference of squares? We have 2 terms. We're subtracting. They both have to be perfect squares. And you're going to find out that 9x squared is a perfect square. 3x squared would give us 9x squared. And our b term is going to be plus 2 and a minus 2, because 4 is a perfect square. So this would be the completely factored form of this right here. All right, our next one in the bottom left, we have x squared minus 13x minus 140. So if you try to factor this, well, what we should notice is, well, there's 3 terms, so it's definitely not a difference of squares. We should be thinking about the trinomial patterns that we know. Your a is 1, your b is negative 13, your c is negative 140. So we should be trying to factor this with factors that multiply to be 140, but add up to be negative 13. So this would be like, well, our b is negative 13, our c is negative 140. So you can go through different factors of this, but the ones that end up working for you are going to be, if you do negative 20 times 7, it gives you negative 140. When you add them together, you get negative 13. These would be your 2 values that go into your binomials here. So x minus 20 and x plus 7. We should expect these to be 2 different signs. Remember, if you're subtracting c, these should be different signs. And since we have minus 13x, you're going to end up with the larger number being the subtraction here. So minus 20 plus 7. So this would be the factored form of that third one. Didn't need difference of squares here. That one was just there to see if we remember the trinomials. All right, and our last one, the bottom right. This one's a little more challenging. We'll get into more detail with ones that are a little more challenging tomorrow. But we'll do this one together right now so we can get a little hint of what to expect. So here, notice that we have 3 terms in our original polynomial, so we can't use difference of squares. We could look for a GCF, but we don't have one. So we should be thinking of, well, is there anything we could multiply together to equal this? Now it's in order of greatest degree to least, so we're going to need our 2 terms in the beginning to multiply. Normally we have x and x, but we want them to be x to the 4th. So x squared times x squared. And then we want to multiply 2 terms together that'll equal negative 20, but add up to x squared. So let's think of, well, we have a negative for our c here. So we're going to have 1 plus, 1 minus. And what two terms would multiply to be 20, but then add to positive 1? Well, if you do that in your head a little bit, you might go through some factors. If you do plus 5 and minus 4, you're going to multiply to be negative 20. And then when you do your FOILing, you're going to have positive 5x squared, negative 4x squared. It'll add up to a positive x squared. So this is the factored version of that. And now here's where we have to recognize. You can't do anything with this binomial, but this binomial is a difference of squares. So we're going to continue to factor further, because we can go further with this binomial. X squared is a perfect square, 4 is a perfect square, so your a is x, your b is 2. So this is what your final factored form should look like. First you use a trinomial, then one of the two binomials that we were left with from the trinomial was a difference of squares, so that factors down even further. And here's our final factored form. Alright, so when you're going through factoring, always do GCF first, and then just look for patterns. If you have a trinomial, use the trinomial patterns that we have. If you have a difference of squares, now that's a new method that we can use and factor further. So it's all about recognizing what patterns you can use and what methods are best to factor. That's all we have for today. Have a nice day, guys.